Hi everyone, it's TJ with Avidine. In this video we're going to be talking about an introduction to EFIS interfaces with the IFD. Due to the complexity of some of these EFIS interfaces, this is going to be kind of a three-part series. So in this video it's going to be the introduction to EFIS interfaces. The next one in the series will cover each interface specifically, and then finally a third part to this series is going to be EFIS interface troubleshooting with an Avidine IFD. So stay tuned for the others. In this particular one, we're basically going to do just the introduction to EFIS interfaces and kind of go over some familiarization stuff that hopefully will help the other videos make a little bit more sense when we get there. As always, nothing in the following video is considered FAA approved data. This is for reference use only. For FAA approved data, please refer to the IFD installation manual. Make sure you're looking at the latest revision on that guy. Okay, so to jump in on this, most of the EFIS interfaces that we're going to talk about are going to be ARINC 429 interfaces. So it's important first to understand kind of how the ARINC 429 stuff is laid out on the IFD. So as you can see here, the IFD has two distinctively different sets of ARINC 429 connections. One set for GPS data and another set for nav data. This is where your VLOC stuff would be, your VOR ILS stuff. Okay. The specific data labels are either going to be transmitted from or received by, and all of that stuff is going to be determined by what the configuration settings are on both ends of the system, if you will. But as a general rule of thumb, the ARINC 429 ports you'll run into on the P1001 connector are going to be for GPS. There are also some ARINC 429 options there for RDR 2000, 2060, and 2100 radars, but that doesn't really have anything to do with EFIS interfaces, so we're not going to get into that just yet. But as you can see in this example, this is just from a generic EFIS interface. We've got an ARINC 429 in, an ARINC 429 out for GPS, and then on the 1006 connector we've got the VOR ILS ARINC 429 out. So let's dive a little bit deeper into this. Again, GPS 429 connections are located on the P1001. Here's where we're going to go in to configure those things. Where the GPS ARINC 429 config page is, it's the main ARINC 429 config page. Each one of those settings is going to need to be set for line speed. So your options are either a low speed at 12.5 kilobytes per second or high speed, which is 100 kilobytes per second. And this is the important one. This is the one that can get tricky if you're not super familiar with a specific interface. And that's the data setting. The data setting is going to determine what specific protocol we have set up. One of the peculiar things about ARINC 429 is there are often times when ARINC 429 data, a data line might have more information on it than a receiver is capable of using. So what will happen is the receiver will take whatever ARINC 429 labels it wants or that it's looking for, and it'll just disregard the rest. So that's kind of important to keep in mind. So anytime we're talking about 429, what we want to do is we want to find those configuration settings that allow A, the transmitter to send all of the ARINC 429 data possible, and B, the ARINC 429 receive setting on the receiver end of that to accept as many ARINC 429 labels as possible. And that'll make troubleshooting a lot easier if we kind of go out of our way to look for those things. So the input side, typically we're talking selected course, heading, altitude, airspeed, attitude, air temp, OAT, that kind of stuff. And then on the output side, we're talking the GPS data coming from the IFD out to your EFIS system. So, lat long, ground speed, track info, waypoint info, flight plan information, all of that good stuff. And you'll notice here on this ARINC 429 page there's an SDI setting, and ultimately what that SDI setting does is it ensures that when GPS 1 or GPS 2 is selected as the nav source on your PFD or EFIS system, that it is commanding and listening to the correct IFD. So anytime you've got a dual IFD installation and you've got an EFIS system where from the EFIS you can select whether you want GPS 1, GPS 2, nav 1, nav 2, you want to make sure that you set these SDI settings because it can confuse things a little bit if you don't. So in this scenario we've got dual IFDs installed, let's say. So what we're going to do is on the number 1 IFD we're going to set this SDI for LNAV 1. On the number 2 IFD we would set it for LNAV 2. And then you'll see a VNAV setting down there. And what that VNAV setting is that allows the IFD to send out GPS-based vertical guidance ARINC 429 labels. So what this means is if for instance you're installing an IFD as part of a WAS upgrade, part of a WAS upgrade is adding the capability to the system to do GPS-based approaches, LPVs and such. So what we often get phone calls about on this particular interface is someone will have gone in, they've done a WAS upgrade from an old, non-WAS GNS system to an IFD, and this setting right here perhaps got missed because the complaint sometimes is I don't have any GPS vertical guidance on my PFD. If that's the case, we're always going to recommend check this thing first. For WAS-enabled units and a WAS-enabled PFD that can do GPS approaches, we would want to make sure that this VNAV setting is set to enable labels. Again, enable labels allows the IFD to spit out all of the vertical guidance stuff associated with GPS approaches to your PFD or your EFIS. Now let's talk about the 1006 connector a little bit, where this VOR ILS ARINC 429 out is located. So bear in mind, all of the navigation stuff we've talked about up to this point has been related to GPS navigation. So here's where we're going to get into the actual nav, your VLOC nav information coming from the IFD out to your EFIS system. So here's where that configuration page is. If you look in the top left corner of the picture there, it says 9 of 15. Don't use that as a hard and fast rule because these page numbers can change with different software levels. Not only that, but the number of pages available can change based on how many options are installed. For instance, Wi-Fi, Bluetooth, yada yada. So the main thing here is you're looking for the VOR localizer glide slope ARINC 429 config page. Okay. And you'll notice on this VOR localizer glide slope ARINC 429 config page, there are the same options we saw on the main ARINC 429 page, where we've got line speed and then format, which is going to be the data, the actual setting for that to set the protocol. And you notice that there's also an SDI setting here. So again, this would be for your EFIS system so that you can go in and select whether you want your EFIS to follow GPS 1, GPS 2, VLOC 1, or VLOC 2 would be what this setting directly is going to impact. So we want to make sure that if we've got dual IFDs installed and that is selectable from the EFIS, that we've got this thing set accordingly. So on the number 1 IFD, we would set this for VOR ILS 1. On the number 2 IFD, we would set it for VOR ILS 2. One other thing I want to talk about just real quick before we end this video and get into some of the more specific interface details. If we back up just a second here, and you see this VHF GPS 429, that current format that's set there, the only time you're going to use that format, VHF/GPS, is if you are connected to a system where we have glass enabled. If you're not familiar with our glass enablement, essentially what that does is that allows us to turn GPS navigation deviation information into a spoof of a nav ARINC 429 output. So only in a very small handful of instances are we going to go down that route. This should almost always be VHF 429. If there's any question about whether that needs to be VHF GPS or just VHF, don't hesitate to ping us in tech support. But the next video in the series that applies specifically to your interface, we'll touch on that again and get a little bit deeper. Again, thanks for watching, and we'll see you in the next one.